All right, Logan and Quentin are far from one another and yelling at each other in funny accents. Logan decides he wants to one-up Quentin and make a really funny high-pitched sound that has a frequency of 763 hertz. In addition, Logan charges at Quentin with a speed of 12 meters per second. In order to make him cower in fear, Quentin is up to the task, charges at Logan at 7 meters per second. So what frequency will Quentin hear? All right, first thing we need to do before anything else, we need to decide who's the source, and we need to decide who's the observer. The good news is there's only two options. It's either Logan or Quentin. So we have to decide who makes the sound. So Logan decides he wants to one-up Quentin and make a really funny high-pitched sound. So Logan makes the sound. That means he is the source. And Quentin hears the sound. So Quentin is the observer. There we go, words. Okay, Quentin is the observer. All right, so that's the first thing I do on these problems. I decide who's the observer and who's the source. You need to know that, otherwise you don't know what FS is and you don't know what FO and VO and FVS. You have to know who's the source and the observer, so write them down for starters. Once you've done that, you need to label what the different values are. And the values are always FO, FS, V, VO, VS. So when I do these problems, and it's pretty obvious when you're doing these problems, it's going to be a Doppler effect problem. It's going to talk about sound and speed and that. It's very obvious if it's a Doppler effect problem. Okay? So I just write all 5 things down. I just write them all down. And then I go in and I figure out what they are. So FO is the observed frequency, the frequency that's heard. Here we are in A. What frequency does Quentin hear? I don't know. So I just write down question mark. That's what I'm solving for. Okay. FS, that's the frequency that's made. Logan makes a frequency of 763. That means the source is 763. That's the frequency that's actually made. Okay, V is the speed of the wave. You'll notice I didn't say that anywhere, but we know what it is. We're talking about yelling through the air. It has to be the speed of sound, which is 340. And if you look at practice 1, you'll notice I gave it to you. You don't have to memorize that number. Okay, VO is the observer's speed. Quentin is the observer. How fast is Quentin going? So Quentin charges at Logan at 7. So the observer's speed is 7. And Logan, who's the source, charges at Quentin at 12. So now we've got all the things. We know who the source is. We know who the observer is. We know all the values, frequency, velocities. We got them all. We got everything we need. So now we're ready to set up the equation. And that equation is FO equals Fs, which is 763, times V, which is 340, plus or minus, just write it as plus or minus for now, VO, which is 7, over V, which is still 340, minus or plus, notice I'm leaving it like that for now, 12, the Vs. So there's my setup, 763 times 340 plus or minus 7 divided by 340 minus or plus 12. So now we need to figure out what the signs are. And here's how we do it. We ask ourselves, what are they doing? What's going on? towards is top, away is the bottom. So we actually need to make this set of knowns and unknowns a little bit more detailed. Because we can't just say 7 meters per second. We can't just say 12 meters per second. We need a direction. We need to know which way they're going. So it says Logan charges at Quentin. At means towards. So VS is towards. And I'm just going to write that on my paper. There we go. And I'm even going to spell it right. Okay, so he is going towards. The source, Logan, is getting closer, so it's towards. Okay? Then it says Quentin is up to the challenge, also charges at Logan. So he is also going towards. And the reason I do that is to help me with the next part, which is picking the signs. So when I pick the signs, I need to decide whether I pick the top sign or the bottom sign. Notice I didn't say whether to pick positive or negative. I have to decide if I pick top or bottom. So the observer is going towards. Towards is the top sign. So here's my observer's speed. The top sign is positive. Okay, source is towards. Towards is top. Here we go. The top sign in the denominator for the source is negative. So even though they're both towards, one is positive, one is negative. So don't, pretty please with sugar on top. Don't say to yourself, towards is positive and away is negative. Oh, please don't do that because you're going to get it wrong. Okay? Remember, top is towards, bottom is away. Top is towards, bottom is away. So I picked the towards for both top, top. And now all you have to do is solve, and the algebra is very straightforward. FO equals 763 times, and I just do the math here. 340 plus 7 is 347. 340 minus 12 is 328. And then I do the math. If you need a calculator, come grab one. You're going to need them here. We're going to do a bunch of math. So if you need a calculator, come on down. Come on down and grab yourself a calculator. If you have a calculator, then just get yours out. But if you need a calculator, come borrow one. So you're going towards the top side, so that looks fine. It should be a little higher, but not very much higher. It's coming towards you, so you would pick your top sign and its top sign, so that looks reasonable. Then it's going away from you, and you're going forward, so you're going towards, which would be your top. It's going away, which would be bottom, so they're both positive. So this should be down from here and down from this one. And then the last one would be 0, yeah, because you're now moving, and then the same thing for everyone. So it should be significant. It's not very fun. All right. Here's how I solve it. 347 divided by 328. 1.059. I'm going to round that to 1.06. Yeah, let's do 5.8. And then just multiply that by 763. And we get 807.2 hertz. So he doesn't hear 763, he hears 807. And then I just take a minute and I think, does this answer make sense? Does it make sense that the frequency I hear is higher than the frequency he makes? And yes, it does make sense. They're getting closer together. If you get closer together, the frequency should go up, and the frequency did go up. So let's look really quickly at B. So after a short amount of time, Quentin's resolve fails him, and he turns around and runs away at 7 meters per second. What frequency would he hear now? So Logan's motion is unchanged. So we're solving for what frequency does Quentin hear? So we're still solving for FO. The source frequency that's made by Logan, it said Logan's motion is unchanged. So he still makes 763. The V is still the speed of sound, which is 340. The VO has changed now. So Quentin is doing something different. He's running away at 7. So his velocity value, his speed is 7, but the direction is away this time. And VS has not changed. It's still 12 towards. So when we set up the equation, it's FO equals 763 times 340 plus or minus 7 over 340 minus or plus 12. So then we ask ourselves, what is the observer doing? The observer is going away, so I pick the observer's bottom sign. What is the source doing? The source is going towards, so I pick the source's top sign. And then I just do the math. FO equals 763 times 340 minus 7, which is 333, over 340 minus 12, which is still 328. Divide those out. This gives me 763 times 1.015. When I multiply those together, I get 774.6. So let's see if this number makes sense. So 763 is what's actually being produced. Logan is running towards, but Quentin is running away. So this makes the frequency go up, but this makes the frequency go down. Notice that overall I'm getting closer, so the frequency should be higher, but not very much higher. And that's correct. 774.6 is higher, but it's not very much higher than 763. Kabush. So that's how you go about solving these problems. Decide who's the source and who's the observer. Set up all the values that you're given, FO, FS, V, VO, VS. Decide the direction of the object, of the observer and the source. And then set up the equation, pick the signs, and solve. Like I said, the solving is going to be the easiest part. The hardest part is figuring out the signs and getting the right knowns and unknowns and directions. That's the hardest part. So if you can get through that part, the math will not be difficult. All righty.